Another relative velocity question from this time for 2018. Um, so two parts. There's only a certain amount of types of questions they can ask, and the river is usually very important. And then it's either a kind of a wind or airplane type thing as well, or a man walking around on a hill looking at the wind. So, okay, this guy, part A, the aircraft travels at a speed in still air, so that's so the velocity of the aircraft in relative to the wind is 400. Okay, Q is north of P. So Q is somewhere up here, P is there. So it's setting out to fly from P up to Q. And how much is it? What direction should it set its course if there's a wind of 6 blowing from the northeast? So just be careful about where these come from. So you can do this separately if you like, just to settle on it. So it's blowing from the northeast. That means it's coming from there. So the vector is that way. So it's coming from there. So just start, usually you kind of start the vectors at the origin just to get an idea. And you know it's a 45-degree angle. Wind, so the velocity of the wind is 60. And you can kind of just leave out the units. I know that's a kind of a bit heretical, but as long as all the units are the same, just leave them out at the start. You can pop them in later. It just makes the diagrams a little bit easier. Okay, so that's where the wind is coming from. Okay, so yeah, right. So the wind is going that way. So let's draw in the wind first. So it's and you're going to be going out that way at some stage. So let's to try and counteract the wind. So that'll be, let's call that X. And so you're going to have to fly. So the wind, velocity of the wind is 60, and you're going to have to fly this way in order to end up there. Because, okay, so you want your equation is VAW is equal to the velocity of the aircraft minus the velocity of the wind. Or you could say that the velocity of the aircraft is equal to the velocity, its relative velocity plus the wind that it's being relative to. So let's see if that's the case. So VA must be equal to the same vector as this guy, as those added together. So VA, so that's velocity, that's where you're setting out. So, okay, VA goes from P to Q, which is what we want. But the combination, VAW, goes out here to X, and then the wind kind of blows it back there. So that's if they were acting separately. When they're acting together, they end up with this. So the resultant of that vector must be equal to the resultant of these two. Okay, so there you have it. Now, what do you know? Well, that angle there is 45. And do you know anything else? Well, okay, so we can put that through here, and that means that angle there is also 45. So you know that is coming from the northeast. So relative to the horizontal, it's a 45-degree angle. And they're alternate angles. So relative to the horizontal there, you know that's 90. So we now know the combination of those two lads there, which is 135. All right, do we know anything else? We know VAW is 400. We know that's 60. And we need to know what direction they're going to go. So let's call that angle, let's call that angle Y, that angle X, let's say. Okay, so we now know one of the angles in a triangle, and we have these two other ones, and we need basically this one, Y, is what we're looking for, and probably VA as well. Okay, so, right, so you have a triangle there. We can do it out again, just to make it a bit clearer, if necessary. Y, X, that's 135. Okay, 460, and we don't know that one VA yet. Okay, so that, because you've one angle, I mean, the cosine rule, you in almost all these cases, you have a choice. The sine rule will almost always work for all, if you just apply the sine rule. And then if you have one angle, just one angle, then the cosine rule would work as well. So the cosine rule there, you could work out VA from that. But let's try the sine rule. So this is a nice easy one here. Sine 135, you have both here over its opposite, 400. And that's equal to, and then equal to this angle here, sine y over 60. So now, clearly from this one, you can get the angle y. All right, so you could then, and it says what direction, it doesn't actually ask you what magnitude, just what direction should the pilot set its course if the wind is blowing there. So really all you need is the angle y. So it would say you'd be setting out, well, you have the magnitude, you'd be setting out with a magnitude of 400 at an angle north, y degrees east. So that's pretty trivial there. You can work out your sine from the sine rule. Always useful just to put in the other sign just in case. So sine x over VA. So from this, you can now find the angle y, which is great, and what you need. And then how far is the aircraft from P after 20 minutes? After 20 minutes, so half an hour, so 20 minutes, and that's where they try and trick you out. So that's the first time where everything else has been in kilometers per hour, so just watch that. They're always trying to trick you at some stage. So that's equal to a third of an hour. Okay, so we need the velocity VA for that. Well, we have sine y there from that one, which will give us y. And then once you have two angles in a triangle, then x is going to be equal to 180 minus 135 minus y. So we now have x. So we can now pop that in there and we'll get VA. And then velocity is equal to distance over time. So it's saying how far has the aircraft traveled? Well, the distance along here is going to be equal to VA by a third of an hour. All right, so that's that one. So sine rule always pretty vital for those guys, or the cosine rule. But the sine rule is nice. Write out all three. You have usually, all three equations for the sine rule. So your sine one angle over the opposite side, sine equals the sine the other angle over the opposite side, the sine of the third angle. So write out all the three angles, and then find out which one. Which you always have one completely, and then you probably have one variable missing the other, and you can find that. Okay, rivers. Now these are very popular ones. River flows at constant speed, and you're asked the two classic questions: how long does it take for the shortest time? And then what about the shortest path? Distance traveled by the shortest path. The nearest reachable point downriver from the bank. So this is so let's just look at the general situation here. So the general situation is where you have the woman sets out here. So she sets out with a vector there. So V woman river. So that's if the river was still, she could travel at that, and that's 1. Yeah. And then you have a river that's flowing at 4, so that's 4 times the vector, so about there, let's say there. So the river is equal to 4. And then, so to close the triangle, then your actual velocity of the woman must be this to close the triangle. So that's your general equation. And then let's just put in the angles. So that's the angle A that you set out at. That's the angle C that you actually, the woman actually travels at. And then let's just say B is in the middle. And then by alternate angles, you get that is equal to this. And C is the alternate angle here. So you have a triangle here with angles A, B, and C. And this is the general case. You can write this triangle out for every one of these. And usually it'll kind of simplify, but it's useful just to write it out like that. Okay, so the shortest time, every then example is an example of, every sort of subset is an example of that. So in the shortest time, what does our triangle look like? Well, okay, looking at the general case, you set out, okay, first thing to notice is the river traveling faster or slower than the woman can travel at? And you can see the river is traveling much faster. So what that means is there's no way she can counteract all the river and travel straight across directly. Not possible, because the river is 4. So if the river was traveling at 0.5, let's say, it would be possible for her to travel on an angle and end up going very efficiently directly across, because she'd be able to counteract all the river flow and also be able to put some energy into going straight across. Not the case in this case. Okay, so in this special case, all you want to do is get the shortest time. So for the shortest time, we want to keep this angle straight up to 90, so that we're putting all of the woman's relative speed into just going straight across. So V is equal to 1. V woman river is 1. So she'll end up going out somewhere here. And that's 4. And you actually have a right angle triangle, because you want her relative velocity to go straight across, put all the energy into going straight across. You're not putting any angle at all. So A is now a right angle triangle. And so C will be quite small, because you're not counteracting anything, and it'll be quite small, which means it drifts way far downstream, but we don't care about that. And then, just like our projectiles, we look at things in the X and Y direction. So, and all we're interested in is, we know the Y distance, which is 60. Is it? 60 it is, yeah. So velocity is equal to distance over time. So the velocity in the Y direction, in this case it's 1, because we're putting all our energy in there, is equal to distance in the Y direction over the time taken. So it's equal to, so the velocity 1 is equal to 60 over t, and t is equal to 60 seconds. All right, so we end up with that. Now this one, the distance travelled by when it crosses by the shortest path. So in this case, what does the triangle look like? Well, we want the shortest path, so we want that angle smaller, and then so C will be kind of bigger. So with same triangle here again, A, B, C, and just fill in those lights there just to make it clearer. So in this case, we're putting in our angle 1, but we're not, we want the shortest path, which means we want to keep that. We want to keep the drift downstream as low as possible. So we want to keep the angle C as big as possible, because we want that distance there to be as short as possible. So this is the distance we're talking about. We're going to call that X. And we want that to be as short as possible, because if we don't counteract some of the river, then it'll end up like this, and X will be huge. So we want C to be as big as possible, so that X will be as small as possible. Okay, so let's have a look at what that looks like. Well, sine rule. So this is 4 here, and that is X. So let's have a look at it. So now, strictly speaking, because these are distances, X is distance, then we have to put in our T for time here. So let's say it moves for 1 unit, we wait 1 unit of time, then you'll go across by 1 unit, and the river will have flowed down by 4 units. So put in the T just to make them distances. Okay, so now sine A over its opposite, which is X, is equal to sine B over its opposite, which is 4t, equals sine C over its opposite, which is 1t. Okay, so let's have a look at this one. Now, we're not a huge fan of this because we don't know the angle or x yet. So let's not look at that yet. So this one looks a bit more promising. So we're saying now, so which is the angle? Well, sine C now is going to be equal to sine B by, apologies, sine B is equal to a quarter of sine C. Have I got that right? I haven't. Okay. Sine C is equal to a quarter of sine B. Okay. Now, why are we doing it in terms of sine C? Well, we don't control sine C. Okay? The woman controls the angle A, the angle at which she sets out at. She chooses that, so she sets out at that angle. Now, really, that's like choosing B as well, because once you choose A, then B is just the full angle 180 minus C. So basically, you choose A and you end up at C. So C is the angle that you end up with after you make the choice of A and B as well. So we're finding out, and we need C to be as big as possible. As you can see there, to make X as small as possible, we need C to be as big as possible. Now, in the extreme case, what we would like is for C to be 90 degrees, yeah? And that would give us our minimum value of X. So that would be the ultimate. We want C to be as big as 90. But that's not going to be possible because the river is traveling 4 times faster than the woman, so it's just not going to be possible. But we want it as big as possible. And let's see how big we can make it. Well, here we have our expression for sine C, which is what we end up with. B, we're choosing really, because it's implied in choosing A, we kind of are choosing B. It's just a consequential, because the whole thing, A and B, are just the resultant angle you end up at minus 180. So let's have a look at what we get from B. So we want to maximize the angle C, which means we need to maximize sine C. Now, why is that? Because, okay, they're both connected. So if C is 0, say, then sine is 0. That's when it's at its minimum. If C is up at 90, then sine is 1. So as you can see, the bigger the angle, the bigger sine is, okay? So we want to increase the angle as much as possible to decrease that distance. So now we want sine C to be at a maximum. So how do we maximize that? Well, look at this and see what we can maximize there. Can we maximize a quarter? No, because it is a constant. So we need to maximize that. And in order to maximize any trigonometric quantity, that is going to be equal to 1. So sine C max is equal to a quarter by this being 1. Now, what does that say for B? It says sine B is 1, which means B is 90 degrees. And we end up with sine C max is equal to a quarter. So that gives us, so that is equal to 90 degrees. So that's an important result. And what that means is that our triangle there, in order to minimize this distance, then that triangle there is a right angle triangle. And that's an important result. So it looks something like this, where that is a right angle. That's X. That's C. That's A. So, and C is the one we're concerned with. We need to find X. So we now have C here. We now know with that is 4 and that is 1. So sine C max is equal to a quarter. Okay, so that gives us our maximum angle for C. So that gives us the angle the right angle for C so that our distance is minimized. Okay, so now that'll give us C. So we have sine C equal to a quarter. So that will give us the angle C. So now we have the angle B, which is 90. We have C. So we now need to just find A. Well, A is simple because that's just 90 minus C. So now we need to find X. So the distance X is going to be equal to cos of C. So cos of C is going to be equal to X over 4. So X is equal to 4 cos C. So we can then find the distance. Once we have the angle C, we can then find the distance X, which is the shortest time. So our right angle triangle here looks like this, C, and we have 1, 4 on the hypotenuse. Sorry, so sine C is equal to this, and that is X here. So that will give us your final X on that one. So that one is drawing your general triangle, your A and your C. You need to maximize the angle C in order to minimize X. So do your sine rule. That one doesn't help you much yet, so do the one that does help you. Sine B over this, so that gives you an expression for sine C. You know you need to maximize the angle C, so you need to maximize sine C, so that gives you a quarter for sine C. And then you can find X from just right angle triangle trigonometric from that.